In part one of the video, I show how to use Sagebox at a Hello World level by building a Sierpinski Hello World program that uses Sagebox at a very simple beginning level. In part two of the video is when I build the Sierpinski Triangle to show the program that we showed in the introduction. The Sierpinski Triangle is kind of the Hello World of GUI programming in a sense, because we're really just drawing a triangle over and over again recursively. But we also add this nice gradient in the background and these two fonts of different sizes up above. And we also have this input box that allows us to enter the Sierpinski level over and over again interactively, rather than the need to compile the program just to change the level. So let's start by creating a new project or folder in Visual Studio Code for C#. So I select Console App, and then I give it the directory path where I want the folder, and then I set the project name to Sierpinski, and once I do that, it creates our Hello World program for us. So we just have one line of code to print a Hello World program, and I'm going to label this Hello World from C#. So when we run it, we get our expected Hello World from C# on the console line. As I mentioned, the Sierpinski Triangle is kind of a hello world of GUI programming because we're really just printing the same triangle over and over again recursively. To do that, though, we'd like to have a graphical window. So let's create a Sagebox Hello World program where we're using a window. A window is not required in Sagebox. It's just one of the many options that we have. To convert our Hello World program here into something that uses a Sagebox library, we just need to copy sagebox.cs into our current project, and then suddenly we can see that sagebox.cs appears in our file list in the left-hand part of our project window. And to use Sagebox, we simply state using sagebox.main. And now we can use sage.newWindow to create a graphical window, and you can see the documentation come up to the left as we type it out. We can use keywords to set the size and shape and other components of the window. Right now, we're just going to use no parameters to create a default window of 1200 by 800 pixels. So I'm going to copy the console.write line and change it to win.write. We could write exactly the same thing, but I might as well just write Sagebox Hello World. And when I run it, you'll see a blue flash very quickly. If you didn't see the blue flash, let me play it again in slow motion. So as you can see, the window actually comes up but then disappears very quickly. And the reason it does is because the program ends right after we write out to the window and to the console, because there's nothing to stop it from entering back to the operating system. So what we need to do is we need to stop the flow of execution so we can keep the window from closing down until we want it to. There are many ways to do this in C#. One way to do it is to use a function called sageExit button, which brings up a window with a message and an OK button. It states that the program is finished, or we can put a personalized message in, and it waits for us to press OK before continuing. So when I run the program now we can see the Hello World from C# in the console line, and Sagebox Hello World in our graphical window, and the window from sageExit button waiting for us to press return to continue program execution. When we run this program now, we can see our message in our graphical window, but it's also pretty small. But since we're in a graphical window, we can do a lot of things with the text and graphics. So let's go ahead and increase the font to a font of 100. We can do this by using the keyword namespace. KW is the keyword namespace inside of C#. And so what I can do is I can enter kw.font, and we can see the documentation for font come up, and I can just enter font 100. And now when I run the program, we have a nice big message in a 100-point font in our window. We can string together keywords. So for example, I can use kw.center, which will center the text in the window. So when I run it, now we have the nice big font centered in the window. And I can also do many other things. So for example, I can enter kw angle and enter 45 degrees. So now when I run the program, we have the message, but now it's at an angle of 45 degrees. We can use curly braces to affect the text in the right function. Let me get rid of the angle here and also the font. And when I enter 100 in curly braces, it sets a font to 100. So when I run it, we get the same 100-point font. And when I enter a color, such as green or just G, and then close it with empty curly braces, now when I run it, we have the word hello written in green. We can also use multiple lines and multiple fonts. So when I enter a new line and a 25-point font with the color of cyan and run it, now we have this nicely formatted message consisting of two lines with two different fonts and two different colors. Since we're really just drawing triangles outside the niceties we add in later, let's go ahead and draw a triangle. Let me get rid of this console write line. We don't really need that anymore. And let's specify 3 points, A, B, and C. Now we know that the center of the window is at 600, 400 because we used a default window with a size of 1200 by 800 pixels. So we can just define our 3 points A, B, and C kind of about that center at 600, 400. To draw a triangle, we just call win.drawTriangle with our points A, B, and C and a color. In this case, I'm using a text-based color yellow, but we can also use a symbolic pan color or sage color to keep it symbolic since we're using a compiled language. For this type of thing, I like to use the text colors because it's really just easier to read and easier to play with sometimes. So when we run it, now we have this triangle in the middle of the screen that has a basic size of 1 pixel all the way around. We can change that by using the keywords in the same way we did before. We can use kw.pen size to affect the pen size. We can see the documentation come up. So setting a pen size of 20 now has a pixel width of 20 all the way around the triangle. Since we're in a compiled language, sometimes it's nice to use symbolic values rather than text values because it's more efficient and it protects us from errors. We see them at compile time. I'm going to use a pan color green here, and when I run it, you can see it's kind of a dull green. In Sagebox, we have pan colors and we have sage colors. Pan colors are just Pantone colors that are well defined out there, and sage colors tend to stick more to primary. So when I use sage color green here, it's much brighter. But I'm going to go back to the text yellow because sometimes it's nicer to use text just to play around and experiment, maybe to change it to a symbolic in a refactoring stage later on down the road. We can also call filled triangle, in which case we don't need the pen size here. When we call filled triangle, it draws exactly that, a filled triangle instead of the open triangle that we drew earlier. So now we have a nice filled yellow triangle in the middle of our window. So let's change this from a Sagebox Hello World program to a Sierpinski Hello World program. To do that, let's move this text down to the bottom of the triangle. Since the bottom of the triangle is at 600, let's move it to 650. And I can use this using the pause keyword. And instead of center, I'm going to use center X, which will center it in the horizontal axis, but keep it where it is vertically. So I can express pause 0, 650 to put it at vertically 650 below the triangle. We can also use a function called writeXY and give it the X and Y coordinates in the beginning of the function, but I'm just going to go ahead and use the pause keyword here. So when we run it, we have our big triangle in the middle and our Sierpinski Hello World text in a big font down below it, kind of centering it as a nice Sierpinski Hello World program. So that's a basic introduction to using Sagebox with the Sierpinski Triangle as a context for kind of a Hello World program. In the next video, I show how we use graphics and controls and build the Sierpinski Triangle.